Okay, let's pick back up and finish these notes. So, come on. We were in the middle of example 9. We did the A one. So we'll pick up here. Now, if you're in second period, go watch the rest of the part 1 video because we didn't get quite as far in second period as we did third period. Okay. What are our directions? Oh, got to factor it. So first, let's write everything in descending order because that just makes life easier. Factor out the greatest common factor. All right, and think about it. X squared. If I were to let u be an x squared, then u to the 4th would be the x squared squared. That'd be u squared. So if you can factor this, you can factor this. So I'm going to say what multiplies b12 adds to be -7. It's just going to put x squared in the front. And I'm not done with this one because that's still the difference of 2 squares. So it turns into x plus 2 and x minus 2 is the 2 more factors. Okay, see this one. Let's factor out a 4x squared. That's going to leave me an x to the 4th minus a 5x squared plus 6. Again, if I let u be x squared, then I'm sitting here with a u squared minus 5u plus 6. What multiplies to be 6 adds up to be -5. That'd be a -2 and a -3. So I'm just going to start out with an x squared each time and put the -2 and the -3. And then I'm good. I have no idea why I capitalized factoring right there. I should probably fix that. But if you're going to solve by factoring, it doesn't do, remember, factoring is when you turn a problem into a multiplying problem. It does not do you any good to have it set equal to any number other than 0. So the first thing I'm going to do, actually, I'll tell you, the first thing I'm going to do is divide by 2. Divide both sides by 2. Because why wouldn't I? That makes my numbers easier. I can't divide both sides by x because I don't know what x is yet. And what if x is 0? And I'm sitting here dividing by 0. So that's just a rule. Like, you don't have to divide that 2 out. You can get all of your factor the greatest common factor, blah, 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 blah. But it's fine to factor a constant, to divide both sides by a constant as long as that constant isn't 0. But never divide both sides by a variable. Okay? So now I'm going to get all on one side, set it equals 0. I'll factor the x out. And let's see what we can do right here. Ooh, that's a perfect square trinomial, so there's really no reason for me to, what multiplies be 9 adds to be 3 when I know that's an x minus 3 all squared. So x is either 0 or 3. Now, I want you to notice something. Sometimes you'll see people do this. They'll say 0, 3, or 3. But that's kind of silly. Like, we're solving this thing. The things x can be is either 0 or 3 to make it true. But did you notice when we started, the biggest power was a 3? It means there's going to be 3 answers. The biggest power is 2. There's going to be 2 answers. The biggest power is a 1. There's going to be 1 answer if there's an answer. That tells you how many solutions there are. It's just they don't always have to be real. So you don't always get real solutions. And sometimes the same solution repeats. So there's 3 answers. It just so happens that 2 of them are the same thing. So what people will say is 0 and 3 are your roots, but that 3 had a multiplicity of 2, which just means it showed up twice. When we get to the second half of chapter 4, we start graphing things, you're going to see why that's so important. Right now, it really doesn't make one hill of beans difference to you, but later, crazy important. So this one, I could totally divide both sides by 5. Or I could factor the 5 and the x out. It's completely your choice. And then keep factoring. That's an x minus 4 all squared So what makes a 5x 0? 0. What makes an x minus 4? 0. 4. But this one, because it's squared, would have shown up twice. It has a multiplicity of 2. Some people will call it a double root. You'll hear that. They'll say it's like a double root. That means it's the root. And roots are just the solutions to equations. It shows up twice. Find the zeros of it. So we're trying to figure out what makes this 0. So how about we factor out a -2 to start with. And then again, if we let u be x squared, this thing's a u squared minus 8u plus 16, which is a u minus 4 all squared. So instead of u, we're going to put an x squared minus 4 all squared. Now this is a little tricky because x squared minus 4, that's a difference of 2 squares. So what it really turns into is an x plus 2 all squared times an x minus 2 all squared times that -2. So this is what our function is. And they want a list of the zeros, which are just the x values that will make this thing equal 0. And they are -2 and +2, and they both have a multiplicity of 2. Or they'll call them double zeros, because they're zeros and each one showed up twice. Find the zeros of this. Hopefully you've got where I can just go straight to here. Oh, wait, I don't even have to do that. It's a perfect square. 9 and 9 make 18, make it a negative. So this is an x plus 3, x minus 3 all squared. So our zeros are -3 and +3. Both have a multiplicity of 2, or you could call them both double zeros. Now notice I didn't put x equals those. It's because it's just saying what are the zeros? What are these x values that you would plug into this function and get a 0 out? You just list them. This one, solve, not find the zeros. We're going to solve it. Got to get it set equal to 0. The biggest power is a cube. Let's make it positive. Subtract 6x squared from both sides. Add 4x to both sides. Oops, that's an x, not a 0. Let's factor a 2x out. And let's see if we can get this thing factored. Ooh, now the only way it's going to factor is if that's 1s. No way I'm making a 15, so it's not going to factor. So I do know one value of x already. Like to make that 0, it's got to be 0. However, I don't know what makes this 0. So let's do quadratic formula because I don't really want to complete the square on that. They'll have fractions, and I just do not deal with that. B squared minus 4ac all over 2a. 225 plus 8. That's what, 233? Oh, 233, not 333. Does 233 clean up? Get a calculator. I can't think of anything. Let's see, 6, 7, 8. I can't think of anything that goes in 233, but I better not give up on it until I make sure. Seven won't be an 11, 13, 17. No, it's too far. So there's my other two answers. Either 15 plus the square root of 233 all over 4, or 15 minus the square root of 233 all over 4. So quadratic formula is going to show back up too. And, that's it.